And we are back. So let's go ahead and discuss in a little bit more detail how to deal with the cell potentials of a battery, basically determining the voltage a battery can produce. For standard situations, basically 25 degrees Celsius, 1 atmosphere of pressure, and the concentration of the aqueous solution, 1 molar. Or anything that is different from that, that would be a non-standard potential. So, and we talked about this before. The standard potential of the cell is the difference between the anode and the cathode. And it's going to depend on which one is being oxidized and which one is being reduced. Once more, 25 degrees Celsius, 1 atmosphere, and 1 molar. And it's calculated from the values we saw on the table of the appendix that are based on the reduction of the metal. And we saw that on the reaction we did earlier, that the zinc was being oxidized, the copper was being reduced. So if we put it together in an equation, that's what we get. And then we found the reduction potential of the copper. And we also found the reduction potential of the zinc, because even though the zinc is the one that is being oxidized, we always use the reduction potential. The formula with a negative or a minus will take care of flipping that value. So always use exactly the values exactly the way they are presented on the table. And we saw that the cathode, which was the copper, was 0.34, and the zinc, which was the anode, was 0.76. The fact that it's a negative value tells you that the possibility of reducing zinc is very small. It doesn't want to be reduced. That's why the value is so low. So the reduction potential is an intensive physical property. So it doesn't matter if we have 1 kilogram or 1 microgram, it's always the same. It doesn't change with the amount. The extensive property will change, not the intensive. So even if we have something like this, we do not multiply because it doesn't depend on the quantity. So we don't change those values straight from the table, from the reduction potential table. And it's always cathode minus anode. So let's do a problem like this. Calculate the E cell. So I know that E cell at the standard conditions is given by the E standard of the cathode minus the E standard of the anode. The standard means that is the values from the table, which is on the standard conditions. So the question is, how do I know which one is the cathode? How do I know which one is the anode? Well, we go back to the beginning. We assign oxidation numbers. An element by itself, 0. Oxygen is always -2. There's 6 of them. Altogether, it has to give you -1, so this is +5. The ions is the same as the charge. Oxygen is always -2. Altogether, it has to give you 0, so this has to be +2. So we can see that the nitrogen is going from 5 to 2, is becoming less positive, so the nitrogen is gaining electrons. So the nitrogen is being reduced. On the other hand, the aluminum is going from 0 to 3 plus, which is becoming more positive, which means it's losing electrons. So the aluminum is being oxidized. So let's clear this up. So the aluminum is being oxidized. So the aluminum is being oxidized, and where the nitrogen is being reduced. So oxidation, a vowel, that's my anode, and reduction, a consonant, I believe I said constant before, a consonant is going to be the cathode, a consonant with a consonant. And E cell, E cell is going to be E cathode minus E anode. So let's find aluminum going to aluminum 3 plus on the tables. Aluminum going to aluminum 3 plus. I don't see it here. Aluminum, actually aluminum 3 plus going to aluminum because we're looking for the reduction, right? I don't see it there either. So where's my aluminum? Let me look again because I ran out of the table. Right here. So aluminum 3 plus becoming aluminum, that's going to be negative 1.66. So the anode is negative 1.66, and that's being taken from the cathode. The cathode is going to be nitrate becoming nitrogen monoxide. So nitrate becoming nitrogen monoxide. So all that together is going to be 0.96. So this is going to be 0.96 minus 1.6 negative. That's going to give us E cell is going to equal 12, 15, 16, 2.62, and it's going to be positive. So this is going to be definitely a spontaneous reaction. It's going to favor the products. And let's see what else. This reaction, if you notice that the nitrogen, that will be the whole reaction. So this reaction is not balanced. However, E of the cell is an intensive property. So it doesn't matter if we end up with a 300 over here, that's not going to make a difference. So there's no reason for us to balance this because it's not going to make a difference, and this will be based on that. If we were going to balance it, then based on this, we saw that it's being balanced on acidic environment. So 2.62 would be the answer to this. And here you can see everything better organized. They went ahead and balanced the reactions and so on, but there's not really a need for it since the coefficients are not going to have any effect on the potentials. The answer is 2.62. So quick review or recap of what we just did. First thing we have to do is realize that the E of the cell is going to be given by E of the cathode minus E of the anode. So therefore, you're going to need to know which one is the cathode, which one is the anode. Cathode is where the reduction happens. Anode is where the oxidation happens. And you can only do that by looking at the oxidation numbers. 0, minus 2, plus 5, plus 3, minus 2, and plus 2. And we can see that from 0 to plus 3, that's my oxidation. losing electrons. So that would be what goes in here. So the aluminum is what you need to find for the anode. And we saw how we went for that one, and we found it on the tables, right? And then we use it from there. So following the same approach, you are now ready to do your daily work, and the answer is going to be 0.66. So make sure you check it and all that. Once more, you're more than welcome to practice balancing that. The question on the test could be balance first and then find the E cell. And if you do it, you're going to balance it on acidic environment. pH is acidic, so make sure if you do it, balance it on acidic environment. And then follow the procedure and find and see if you can come up with the right answer. You gotta show your work. And with that, we're gonna say that pending more practice on your part, we know how to determine the standard cell potential. Very soon, we're gonna see how we do it with non-standard cell potential. So once we come back, which is gonna be the last section of the chapter, we're gonna see how we're gonna relate the cell potential to the Gibbs free energy and equilibrium constants. And that's what we're gonna determine also the non-standard. So until the next one, see you soon.